Hi there guys, as some of you know, I've been building a solar furnace. I've been sharing pictures on Twitter, and for that solar furnace I of course need a solar control charge controller. I could use one of these Chinese versions once, but I decided to build my own, and today I want to show you this circuit. Of course this is a learning circuit. I had a lot of problems. I learned a lot of things, and this particular one is it's working, but it's not optimal. So I'm going to build a new one pretty soon, replacing this one. So let's call this one version 1.0. So first of all, let's show you the hardware. The hardware is right there. As you can see, there are 3 jacks at the bottom. That's because my solar panels have jack at the bottom, and my computer fan I'm using has a jack at the bottom. Yep, that's a 12-volt fan, but it's running fine on 6 volts. And I have one of these motorcycle batteries hooked up. So, just like any other, this first one is for the solar panel, middle one is for the battery, and the last one is for the load. Inside I have a lot of components. I'm even using a regular old school transistor because I was lacking a relay. This will not do, but it was working for testing purposes. I also have a indicator up here, 3 7-segments display. It shows the voltage input on the solar panel when it's charging and drawing power from the battery. It's very small amount of power it's using, so don't worry about that. Everything is based on this MV-teknik chip, and for those of you that follow me regularly, you know when there's a green sticker on it, it has a bootloader. Relay, I'm going to need 1 or 2 more of these, so I might change the entire thing into where I got a integrated circuit with a couple of these on and a couple of octocouplers instead, but we'll see. Some diodes, some resistors, and that's basically it. Okay, I've made a fridging drawing, even though I really hate fridging. That's the wrong screen, there we go, that's the right one, and here we are. This part over here, I'm circling with the mouse, it might be hard to see, that's the input, the solar side. The center part right here is the battery part, and the right side over here is the load. So I'm getting 18 volts at 0.2 milliamps solar power. I run it into a LM7812 voltage regulator to regulate it down to 12 volts, but that also means when my solar charge is below 12 volts I won't be getting any power, so that's a problem. And effectively I should be using a LM7806 if there even is such a thing, but I'll find out. Anyway, either that or I'm going to build my own. So but this is just a test prototype, so that works. A couple of capacitors to keep the charge up. I got a relay here controlled by the MV-teknik, and that relay really measures from the battery. You can see I have 2 resistors because it's 6 volts, and I'm working with the the idea of the maximum input I can put into the MV-teknik is 5 volts, so that's a problem with 6 volts, but you can see with 2 resistors in series and drawing power out to the middle, you are effectively halving the voltage. So I'm getting 3.3 volts at max, so I'm able to measure how much voltage is actually on the battery with minor calculations, of course. If the voltage is too low on the battery, it's not off, but I'm stopping the battery at I think right now it's set to 5.5 volts. It's a lead acid battery, so it's fine with very hard charge and very low battery. It's a very old type of battery, so it's good, but that also means it doesn't really have that long a life. Anyway, when the threshold is met, we turn off the solar charge, and that's problem number 1 for version 2. Okay, we'll come back to that in a minute. But when it's at the lower voltage, it's going to turn on and allow the solar charge to charge the battery. And here's another problem. I'm getting 12 volts through the relay right here. Then I'm having the voltage again because 6-volt battery isn't, well, surely it can charge on 12 volts at 0.2 milliamps, but that's not going to be good. So I'm effectively having it again. So I'm charging at 6.67-ish. I don't know why it goes high, but I think it has to do with the capacitor. Anyway, that's what we are charging with, and it's working fine. Again, if we reach full battery, I set it to 6.2 or 6.105, something like that. It's going to turn off the relay again. Okay, that's the battery and the solar side. Then we have the load side over here. That's this part. Effectively, it's just pulling battery power directly through. Well, we're missing a wire here, aren't we? So let's hook that right up. Yeah, you can see that's a problem. It's not going to double ground the motor. That's not going to work. So let's do something. Oh, we're going to get rid of that much. Let's see. Can we do something? No. One of the reasons I really hate fritzing, because I want to get rid of this wire now, but if I press delete, it's going to delete everything down here. That's just bullshit. Anyway, I'm pulling power from this point, fuck fritzing, into the relay up here. Something like that. That's the real one. So ignore that one right there. That's bullshit. Can we change it? Yeah, it's changing anything. Blue. That's fine. So this black one is the real one. This one right here is not. So let's do something like this. So the off one is, ignore that one. Anyway, power into the relay, into the motor. And the fan runs, of course, it pumps hot air into my shed. The MV-teknik is powered through this LM7805 chip, so I'm getting a maximum of 5 volts into my MV-teknik chip, which of course is both controlling relays and battery charge. That's basically it. And since we're done, let's just try this. Yeah. Ooh, fuck fritzing. Anyway, hope you enjoyed. If you have any comments or suggestions, let me know. I'm going to build version 2 of this system one of the newest days, and I'll keep you updated. One of the things I want to update is my relays. They are actually 5-legged. You can see this one is only 4. And I want to, when this turns on, I want it to run the solar power directly to this point here. No, I just wanted to run the motor directly. There we go. So whenever the battery is full, so the battery is full now, it should divert the power from here directly around this way. And of course I should have placed it on this side of the diode, like so. Oh. Fuck fritzing, it's such, never gonna use it again. Here we go. So when this one turns off, it's going to divert the solar power directly into the motor. And the motor is fine with 12 volts. It's actually a 12 volt fan, so no problems there. That's one of the things I'm going to change for version 2. And the relays, well, of course I'm going to change the relays to be relays turned on and off using octocouplers instead of just directly through the MV-teknik. And that's about it. Might do some fine adjustments in the code. I haven't shown you any code yet, but that's really on purpose. We can open it real quick and take a look. There's just a lot of... it's not really user-friendly if you want. Let's roll down here. Solar furnace. There we go. There's no comments, no anything. There's just a few functions: check battery, serial debug, fan control, and it's just going to run those over and over. But one thing that's really important with the code is it's only running every 5 seconds. But what I really want to do is try to work with the sleep function, but I'm not sure the AT-Tiny85 has a sleep function, but I'm going to look that up because I really want to make the entire unit just sleep every 5 seconds, or maybe longer, and then just wake up, do its check, turn relays on and off. But of course that would require me to do something else with the power, and that would require me to add a MOSFET right here and one over here as well, because when this one turns off, we don't want them to turn off the relays if they are on, and the MOSFET can keep it on. You just need to acknowledge that the MOSFET works like a normal switch, so when you click it, it's going to stay on even when you unplug it, and that's what we're going to do when we're going to put this chip to sleep. We're effectively pulling the plug, but the MOSFET should remember its state, and they do, so that's a good thing. Comment, rate, subscribe, and I'll see you next time. Bye guys.